Okay, so completing the square, here's our goal today. We've learned about these forms of writing this quadratic, right? This is that one. On your formula sheet, it would say general, standard. Our goal is we're going to figure out how to turn it into that to that. Okay? You can also go from this to this. This way is easy, this way is hard. So that's why we're going to learn the hard way. Okay? So here we go. So this would be the easy way. This would be standard into general. Okay, so here's the thing you would do. BEDMAS stuff says to square this. Okay? Now, here's something that's maybe you've never thought about before. This squaring does not mean square this, square this. Okay? It does not mean that. Okay, so it does not mean to individually square things. Okay? The definition of squaring means what? Repeating itself in a multiplication sense. Okay? What are you repeating? This, yeah, I call it a bracket family. You're going to have to repeat the family, repeat the family. Okay? Does this make a difference? Don't square each item. You have to repeat the multiplication of the whole bracket family. Okay? So that is different. That's huge. My grade 12, some are still getting that wrong. Okay? You're going to have to know that. Okay, so y plus 7 equals x minus 4, x minus 4. I'm going to write that out twice to show you, hey, look what the definition of squaring something is. Repeat it twice. All right, now you're going to do your grade 9, 10 stuff here. Okay, this is a FOIL, right? F-O-I-L. Can you FOIL, expand that? See what you can come up with and then check that we did it the same. Okay, I am going to collect those together. Okay, and now one more thing. What do you have to do? Subtract 7. Move that over. And it looks like that. So that's general form. Ax squared bxc, right? Look at that. We did it. So that way is quite simple. It's just algebra. Okay, so now we're going to have to figure out how to start like this. How are we going to start like this? We're going to do a bunch of crazy stuff. And what should we get at the end? We already know the answer, right? How in the world are we going to do this? This is what we're learning today. Okay, so I'm going to make you go through a warm-up. Okay, and then through our warm-up, we're going to have to discover how to do this. So here's your warm-up. Can you figure out this? In other words, FOIL it. Okay? FOIL it and collect. Your foiling will make you collect two things, right? The OI. First, OI will collect, and then L. Okay, so I got x squared plus 6x. Everybody can see I did a 3x and another 3x together. And then plus 9. Okay, good. Try it one more time. So x minus 5 gets squared. repeated, multiplied. Okay, we have to make kind of a rule here. Okay, so that was your result, right? So here's what I'm going to think about. There's a bracket number, okay? Our trinomial produces a b value and a c value. Can you connect a relationship? You can also look at this one. Bracket number, b number, c number. The middle number, the end number, is there a common relationship every time? Okay, bracket number to the b value. Anybody think of a rule there? What's happening? What's that? Times 2. Can I use the word double, which is obviously the same thing? Okay, so, right? That's double the bracket number. Okay, so you saw that number there that I got was doubled. Did it hold true? -5, -10. +3, +6, doubled. Okay, that's a good rule. Now, this is the c value. Does it consistently have a relationship to the bracket number? Squared, yeah, exactly. So c will always be square of the bracket number. Okay, does that make sense? That's always the case of a perfect square. All right, so can we go backwards? Knowing that relationship, here's a trinomial. This is called, I call it a perfect trinomial. It's perfect. It's squareable, square rootable. Okay? So what would you square to get that? So think about your bracket number. What does it have to be? Did you think about x plus 7 getting squared? Yep. Okay, because you told me I should double there and I should square there. All right, what's one of those again? Bracket number would have to be subtract 10. Okay, now I'm going to add another level here. This time you have to figure out how to make the trinomial part and the bracket number part. Okay, so what do you think about this? Do you think it'd be easier maybe to break the bracket number first? What would have to be the bracket number here? -6, because it has to do what? Double to that. Now, also, what would the trinomial have to end? +36, right? Okay, and then finish that last one then too. What's the bracket part? And then also, what would that trinomial have to end in? Okay, so I need a +9 to double, and then it squares. Okay, so this is kind of what I'm doing. this part is called complete the square because I have to make a trinomial that is square rootable. So what did I do? I essentially took half of that value. So look at half that value, right? -6 was half of it. 9 was half of it. And then I squared it. So that's what I did here. 18, I took half, which was 9. And then it would have to be 9 squared. Okay, so half squared. All right, here we go. So we had this top example. We already know the answer to this, right? We already know the answer. Okay, step 1 is move C. Step 1 is to move C. I don't want that there because it's not perfect trinomial. Remember, the goal here is to finish our own trinomial here. So I'm going to go y subtract 9 equals x squared subtract 8x. Okay, move that C out of there. All right, this gives me now an opportunity to make my own trinomial. I'm going to make my own thing because I want something specific there. Okay, what was that rule? What number has to go there according to what I need to make it perfect? Half. You got that value in your head? -4. Okay, and then square 16. Okay, do you know that this thing right here will always be positive? No matter what. Okay, negative squared, positive, positive squared. Okay, so that was step 2. That's what we did, right? Create your own thing. Okay, what happens on a playground when you're on a teeter-totter and then you just like throw something onto the one side of the teeter-totter? It's not bouncing anymore, right? So what should I do? I should bounce it back out. Okay, so that was my step 3. I'm just going to call it bounce. So if you create something on the side of equation, that's not legit. You can't just put anything you want. But if you do the same to the other side, you are okay. You're keeping it equal. And then step 4 is to make it into your form. Okay, so do we know what our form looks like? So this will be y plus 7. Okay, I don't need a in the front. We don't have a multiplier because it's 1, right? 1 x squared. So I don't need the multiplier, brackets squared. Okay, this is just a 1. So we don't need to write that part. And x subtract 4. Okay, are you checking? Does that bracket number double and square? Is that how we started when we were at the top of the page? Hey, look at that, we did it, right? Okay, here we go. Let's see if we can go quicker now that we got this down pat. Okay, step 1 was to get that out of there. I don't like it. It's not my perfect thing that I want. Step 2, remember the goal of a square is a perfect trinomial, so we can create it. Okay, so what are we doing? Half, got it, squared makes, did you write? +1. Because half of 2 is 1, and then 1 times 1. Step 3, balance it back out. If you added one, if you added a pound to the teeter-totter over there, you got to add a pound over there. Step 4, finalize it. So y subtract 4 now. Okay, I don't need to write a multiplier here again because it's just 1. Bracket stuff squared. And then your number again is thinking it has to double and square, right? That was what makes it all perfect. Okay, now we're going to amp it up a notch. What is the difference here? What's an A? I have an A now. I have not just a 1 there. So this is going to create a little bit more stuff, okay? So step 1 is called move C. Same thing. Nothing new there. Okay, so we're going to think about our format here. So everybody knows what our goal is, right? This is our goal. So let's think about what's going on with this A. Can I say that A is kind of detached from all that square stuff right now? Yeah. Okay, so we kind of think like that. We're going to factor it out or detach it. So I'm going to call factor out the A. So this is the new thing. Think about bed mass. All this stuff is squared, then multiplied. So it's the squaring part and the multiplying part have to be separated. Okay, so this is what it looks like. 2 brackets. Detach the 2. Okay, now what do you have? Instead of 2x squared, now we have 1x squared, right? Because you detach the 2. Okay, or in other words, 2 times x squared. Check. 2 times, what would be in the middle now? It's not the 16 part, it's minus 8. Okay, so we've detached the 2. Step 3, now we can go again with all of our normal stuff. Step 3, okay, you can only do this stuff if it's a simple trinomial. Okay, once we've detached the 2, we have a simple trinomial. Do you have a number in there? 16? Half of the 8, half of the negative 8 squared. Step 4, balance it. Okay, you're going to put something on this side of the teeter-totter, and it's not plus 16. That's not your balanced number. So I want you to think about that for a second and write a different number. If you put 16, it won't be fully balanced. Anybody thinking about doing something different? Yay or nay, did anybody think of that one? A couple of you thought of that. Where did it come from? What do I have to remember about everything in this bracket? It's multiplied by 2 along the line. So I don't just have x squared, I really have 2x squareds on that teeter-totter, right? I don't have negative 8, I actually have negative 16x's. So I don't have 16, I actually put on a 32 that way. Okay? Y plus 2 equals multiplier. Okay? So this is my last step, so obviously just the form, right? And then, right, perfect trinomial, perfect squared of doubled squared. Okay, maybe I'll skip 4 and save it as a refresher tomorrow, and do 5 because I see some negative in there. Okay, here we go. Move. Okay, number 2, this is where I see the most errors. Here's why. I get people who want to write 64 right now, and that's incorrect. You can't work with a square until it is what? Simple. Okay, so how am I starting the process of making a simple? I'm doing a process of factoring, get out that A multiplier, right? Okay, so I will make a trinomial now in here. Okay, got it? Can't do it unless it's simple. So don't start that process unless you have a simple. Okay, so if I take the -4 out of everything I see so far, I would have simple, right, x squared. This changes as well. What times gets me to that? This times this is the 16x, right? Anything in a bracket times has to make that. Now the creating. Now I can create because I have a simple trinomial going on. Half, got it, squared. Half is -2. -2 times -2. All right, balance. Your answer is not to add 4 onto the other side of the teeter-totter, though. I need a value that would balance it perfectly out. Would you have subtracted 16? Did anybody think of that one? Because I can't forget anything in here is actually being multiplied yet. Form y plus 1 multiplier, bless you, perfect squareable. Okay, then the homework is going to ask you a bunch of other things like, hey, what's the coordinate of the vertex? When you look here, what is it? What's the bracket number? What's the detached number? Opposite, same. What am I doing? +2, -1. What other things do I know? Hey, the multiplier is negative. What's something I know instantly? It's flipping. I'm maximum. It's narrower. Okay. What if I ask you the y-intercept? What does that mean again? X equals 0. Guess what? Where is it faster to look about the y-intercept? Here, 0, or here, make it 0? Boom, because you can get 2 seconds, your answer. What's your y-intercept? -17. Okay? Okay, here's what I want you to do. We're going to check your answer. Checking your answer. Ready? If I'd only given you this, I only gave you that, okay, what should you do to get the vertex if I only have given you this? You should do, what is it? -b over 2a plug in. Remember that? Yeah, you have, that's the strategy. Complete this square, if I'm asking for a vertex, that's the only thing that I'm asking you, don't complete the square, negative b over 2a. Okay? On your test, the only time you do this all is if the question says, show me complete the square. That's the only time you ever do it. Okay? Negative b over 2a is way faster than that. Okay, here we go. Opposite 16 over 2 times negative 4 makes 2. Guess what? Check. We did that part. Same thing. Okay, plug in. What's negative 4 times 2 squared plus 16 times 2? Subtract 17. Ta-da-da! It's negative 1. Is that good news? Negative 1. And when we did it over there, we got a negative 1. So it all works out, right? Okay, flip to your work booklets. Okay, so page 8, question 6. So this question just says what goes there at the end. So what's the whole process? Take half of that, then square it. Okay, that's it. That's all I want. Take the half and square it and figure out what was there. Don't touch the calculator. Okay, ready? Quarter. Think about a pie. Right now you're sitting there with a quarter of the pie, but you now have to half that piece. Now you have an eighth. Half. Okay? Now square that. So now what does that mean? The top is now 1 times 1, which is 1. And the bottom is 8 times 8, which is 64. That's your answer. Okay? So this question is just saying what's there. Half, square, get that number.